Welcome back to another HVAC for beginners. My name is Chris. I am your HVAC instructor in these videos. Today we're going to go over episode 4. We're actually going to go over the one thing that's most important within your refrigeration cycle when it comes to your equipment, and that is your thermostat. And the reason why I say that, your thermostat is basically the brain of the unit. Without the thermostat, the unit wouldn't know when to come on and when to come off. Back in the days when I started out, they had thermostats that were really simple. They were basically what they call mercury thermostats, and what they would have was a little bitty bulb that would have a certain amount of mercury in it. And if you don't know what mercury is a chemical that if you took it and spread it on a piece of paper, it would have a dry effect, but it maintains a consistency of wet. So it's the only chemical out there that is dry but has a wet consistency to itself. So it is used in these thermostats to make a contact. So what would happen is it would have a little spring in it, and you would adjust your thermostat on the right side of it with a little handle, and would have little measurements of temperatures in Fahrenheit. So you want it 74 degrees. You would set it to 74, and what would happen as it's increasing or decreasing, the spring would expand or contract, and there's little 24-volt power connections on each side of that mercury bulb, and as it moved, the mercury would complete the contact of the 24-volt power and would either kick the unit on when it called for a specific temperature for the home, or kick it off when it meets that specific temperature and satisfies the room air, and it kicks it on and off. And that's how it started. And the most critical thing about them is making sure that you used a level and got that thermostat level on the wall, because any variations left or right on the leveling of the thermostat could throw that mercury thermostat off, and it wouldn't get the correct reading. It was real critical back then. But today, we have solid state control boards in them. So I could hang it, turn it all the way upside down if I wanted to, and it would still operate. But it's always a good idea to make sure that you use a level, get it level just at a professional level to make sure that it looks good in somebody's home. But we will be going over the two different types of thermostats that you would see in a residential home. We're not going to go over any commercial ones at this time, but I will explain to you what the corresponding letters mean below, the coloration of the wires that connect to it, and how it's used in the HVAC field, and what it's actually designed for. And it is color coded. Once you get to knowing what you're doing, you can match any color you want, because you would know fundamentally where to connect these. Now, in the thermostat or in the HVAC equipment setup, the thermostat goes from on your wall, and then it has a 24-volt wire setting. It could be, 12 by 4 and 8 by 6. It just depends on the type of wire you're using and how many individual wires are within the wrap. And so when I went to the supply house, I would get a roll of 24-volt wire, or thermostat wires we call it. And they would ask me, you want, 4 wire, 6 wire, 8 wire, 12 wire. It really depends if I'm dealing with a standard heating and cooling system that only requires a 4 or 5 wire, or if I'm dealing with a heat pump that requires 8, 10, or 12 wire. It just depends on what I'm using. So I would get fundamentally what I would do to save money, I would get 1 by 8 with 12, and it would give me 12 wires in there, and the wires that I didn't need, I would just fold back and wrap around it for later down the road. If one of those wires that I'm using shorts out, I can go over to the ones that I haven't used and replace that, and save the customer some money and the homeowner himself if he knows exactly what to do. So without further ado, let's go ahead and get in to the fundamentals of the thermostat and get a breakdown with it. Okay, well, let's go ahead and go over the functions of the control board. And the reason why we call it a control board is the thermostat itself goes into the control board that's in the indoor unit, either it's an air handler or a gas furnace. And the reason why we're starting with this first is because you need to know how this fundamentally works and where the starting point of your thermostat goes to your indoor unit to the outdoor unit, and how it fundamentally operates as a one unit system. In an HVAC heating and ventilation and air conditioning indoor unit, the control board plays a vital role of managing the overall operations of the system. It serves as a central control hub, and that's what I was talking about. This is the brain of the system. Responds for coordinating various functions, ensuring the efficient and effective operation of the unit. Here are some key functions of the control board in an HVAC indoor unit. And the control board is in the indoor unit. It's not on the wall or it's not outside. It's fundamentally inside on your gas furnace or your air handler. The one thing is system control. The control board manages the overall operation of the HVAC system. It receives input from various sensors and thermostats and controls for different components of the unit controlling, including blower wheel, compressor, fan, and damper actuators. And what they mean by damper actuators, if you have a system that, say like you have a 2-story home and you have a 5-ton system, and it fundamentally can't cool the upstairs efficiently, it maintains, say, 80 degrees, you can put control dampers in. And what it is they are controlled over to their own function board. And when the downstairs system is satisfied, the upstairs thermostat that it goes with your control dampers will actually close off the downstairs airflow and then increase the airflow to the upstairs. And then it will increase cooling capacity to the upstairs, which will bring the temperature down in that room at a much faster rate, and then it'll go through that. Basically, it's called a zone system. Temperature regulation. The control board monitors the temperature inside the space being conditioned and compares it to the desired temperature set by the user. So basically, it has a sensor in there that monitors the temperature that's coming across it. That's why you see most thermostats are in the hallway. And then down by where your return area is usually it's within the same proximity as your return air, because it pulls that air across the thermostat into that exposed area and then goes up into return air and gives that thermostat the proper indoor temperature. So with that, it adjusts the operations of the heating and cooling components to maintain the desired temperature within a specific range. That specific range is depending on the user who wants a specific temperature for their home. Some people like 78, some people like 75, some people like 70. I do not recommend you crank it down into the 60s, because if you get there, the system won't have a chance to cycle. The ruling of thumb is an HVAC system is your system needs to at least cycle 2 to 4 times within the hour. Because if it's constantly running, it can cause that system to freeze up, even if everything is in proper operation sequence. Mode selection. The control board allows users to select different operation modes, such as heating, cooling, fan only, or auto mode. It interprets the mode selected and adjusts the operation of the HVAC system accordingly. Some of these you can actually, when you get the pamphlet and you open up the operations of that control board, you can set that control board to do different things. You can set it for auto only, auto mode, because a lot of thermostats nowadays on the wall have an auto setting on them where you can set what you like your heating temperature, say 72 degrees in the winter, and then in the summer you might want to say 75. Once you program those two in, you can kick over and hit auto, and it'll fundamentally control itself to function if the heat needs to come on or if the cool needs to come on, depending on the temperature within your home. Fan control. The control board regulates the operation of the indoor fan unit's blower fan. It controls the fan speed based on the user's settings or the system requirements, ensuring proper airflow through the system. And let me kind of go over some. And nowadays, some have what they call fan modules. It keeps the fan blower motor from ramping up so fast. It'll have a control module on the back. Allows that fan to slowly come up to operating speed. That allows it to balance pressures as it's first kicking on. Two, a lot of indoor fan units, or the blower motor as they call it, have different levels. You might have high, medium, low, and then that's it. They have different settings on these blower motors depending on the manufacturer who actually manufactures the blower motor. And then, you know, it could be an individual like Lennox has their own, or you get a universal blower motor, and then they'll have different settings. But you will know what settings you need to do on that blower wheel, and we will go over those types of issues in another video. Safety control. The control board incorporates various safety features to protect the HV system and prevent for any potential hazards. It monitors parameters such as system pressure, temperature limits, electrical current. If an abnormal conditions are detected, the control board can shut down the system and activate safety measures. So you have a blower motor that goes out. Some of them have a safety factor that kicks in and regulates a temperature, like through a thermostat probe on the board, and it can actually kick the system into a safe mode, and it'll flash. And these control boards will have a pattern on the door, and it'll flash a certain code, say 3 or 4. You can look over on your nomenclature that's on the panel, and it'll tell you what's going on. A blower motor failure. Say you're in heat mode and the gas valve doesn't stay on beyond its certain measured time, and it kicks it off. You know, you could have a flame sensor that's bad, and the gas valve intermittently receives a signal from the flame sensor to the gas valve to keep it open. If it's not working, it'll kick it off after like 30 seconds to 60 seconds. Communication interface. Many modern HVAC control boards feature communication interfaces such as a Wi-Fi or wireless connection. Nowadays, people have wireless thermostats, and we will go over that one. That's a little different dinosaur in detail. That means it requires no wiring from the thermostat to the board. It is actually Wi-Fi connected. It makes it a more simplifies the connection, especially for the service guy. All he has to do is go in there and program it to make the connection signal, but you must have a Wi-Fi internet connection in your home for that to work. It can't do it individually on its own. It can troubleshoot and diagnose. Back in my day, we had what's called a Thunder Tiger or a Tiger, where I could actually plug into the control board, especially on air handlers that are heat pumps, and I could actually manually make the system do individual things on an individual basis. I can make it hit the gas valve and make the burners work. I can make it hit the blower wheel, make it ramp up. I could test each individual system at the time. Nowadays, it's a little different. They got, you know, plugins for your computer, for your laptop. You can plug into it, and it'll spit back information at you on what's going on how to fix it really quick. It actually makes it a lot easier for the service tech to be able to service and repair the equipment, and for the homeowner. The control board often includes diagnostic capabilities. Remember I told you about the flashing. The assistant technician in troubleshooting systems issues, and may have LED indicators or error codes, and that's what I was trying to tell you. It has a little flash. Those are your error codes and LED indicators. So it's a little LED bulb that's red. It could be yellow. It could be blue, whatever they decide they want to use. On White Rogers, it's red. And it provides information about specific faults or malfunctions within the HVAC system. So let's go ahead and take a look at that control board. All right. These are two types of what I call 24-volt control board. Now, what I want you to understand is real simple. If you notice, these are two different ones, but they almost basically are identical. As you notice, you have your 3, 6, 9, 12 plug-in. You see it on the left and right, which is the little white component that you have a plug-in. This one has a line intercept terminal, and it'll have a mapping and a control setting. It'll have a diagram on where everything goes. If you notice on the left, you'll see down in the corner, it'll say low heat or high heat, cool high. These is basically where your fan controls will go. So your blower wheel connects to the bottom section. One we're going to go over today is basically the wiring mechanism, how to wire a thermostat to your home if this is the type of system that you have still in your home. Let's go ahead and look at the far right corner where it says twin. You have Y, W, R, G, and C. So let's kind of go over what those mean. If you got a pen and piece of paper, this is where it becomes really important. I would behoove you to get you a pen and paper. I'll give you a minute and we'll go over that. Or just pause the video. Y on the system is your cool. That's the cool side of your system. W stands for heat. R is power. That's the feeding power that comes into it. G is your fan control, which is your blower on the indoor unit. And C is common. So if you want to measure to make sure that your 24-volt transformer is working, all you have to do is take a multimeter and go from power, which is R, and C, which is common, and you go across it. If you're receiving 24 volts or 27.2, as we usually see, sometimes 26.8, that tells you that your transformer is actually feeding out into your control board. And we will go over transformers as well in a different video. But this is your wiring setup on how this goes. And even on, if you look at the right-hand corner, if you look at the top, you'll see where it says cool and park and heat, EAC, another park lines. You'll have one for humidifiers. This board actually has connections if you have a dehumidifier that's connected to your gas furnace or your air handler. It can plug into your control board and be controlled from that function. That means it won't kick on until you call for heat or cool. The next one you're looking at, this is the back part of a standard thermostat. This one here, it says look down in the middle, it says control wireless thermostat module number CCZT1 and stuff like that. It even has a way on this one where it's wireless thermostat, but this one is wired in to the unit. And we're going to start from the left-hand side where it has RH, RC, B, C, Y, W, W2, O, TS, and then TS. So this hookup you have here, if you have a home that has a heat pump, this is the wiring at the thermostat for a heat pump. And let me explain the difference. If you notice, everything is color-coded as well. Red is for power. And if you notice, if you see where it says RH and RC, this is the jumper that has to be in play. If you put this in there and that jumper falls out, this thermostat will not work. It has to sufficiently jump over from RH to RC. B, okay, let me explain B. If you have a wire there, B, they call it blue. But if you want this thermostat to be powered by the transformer, if you do not want to use batteries, a lot of thermostats will use 2 AA batteries, sometimes 3, depending on if you're using Honeywell or Maple Chase, whatever it is you're using. The B setting is for your blue wire. And basically you'll come along with your common side on the control board will feed over and go into your B. And that means your power and B, which is your common, you connect those, and this thermostat is now being operated by the transformer. You don't have to have a battery operation. A lot of people will do the batteries because it's just a little bit more simple for the homeowner, and you can actually still put the batteries in there for battery backup. G, the green one, G, remember I told you it's fan. Well, green goes to fan. Y is cool, and that is yellow. So if you kind of see how it's going, R for red, G for green wire, yellow for yellow, white for W2 for heat. Orange is for a reversing valve. This is a heat pump thermostat, and we will get into heat pumps in another video in addition. Black will be your emergency heat connection, and you can see that it's connected all the way over. And remember, it has a warning. It says ensure power, or steading is disabled when you're basically doing any kind of connections. Do not, here's something I want you guys to understand. If you're going to change your thermostat, you need to go to your furnace. You need to find the breaker, or if you have an indoor power supply to it, which most of them do by city code, you need to turn the power off to your indoor unit before you mess around with this. Because if you arc any of those wires, you will pop the 5 amp fuse on it or 3 amp fuse. and or potentially burn out your transformer. You have to turn your power off if you're going to do any thermostat maintenance. Here's a close-up view of another one. And this one's, like I said, this is a standard hookup, okay? On the left is C for common, R for power, white for heat. You have G for your fan, yellow for your cool. But I want you to get a notification on this one. The left-hand side, you'll see a wire feeding in, and it has 4 wires going into the control board. That's coming from your thermostat. The one on the right-hand side that has all the paint mess all over it, that is a 2-wire, and that comes from your outdoor condensing unit. It either is a 2-wire or a 3-wire, depending on the functions of it. When you're connecting your outdoor unit, remember, it's only designed for cooling. So one of them's going to go into cool, and it doesn't matter which color you use. It doesn't matter as long as it corresponds to what you're doing outdoors. So it's one end that goes to cool, the other one goes to common. Okay. Remember, I told you that if you take a voltmeter between power and common, you're going to get the 24 volts. So basically, you're legging one end of it over to common and the other one for cool. So when you kick on your thermostat and call for cool, it makes a feed over and engages power to the cool side, or Y, and it tells the outside condenser to come on. And that's why we call it control. I call it control wire. Most people do. If I go into United Refrigeration, I tell them I want thermostat wire or control wire. They know what I'm talking about. The LED bulbs or LED indicators that I was talking about, these are green. If you see them, they're right below there. And these will signal back and forth if there's a problem within the system. Most of your control boards, are either White Rogers or other types of company. A lot of them use White Rogers nowadays. And that's what you look at. It's a simple setup, but this is how you would wire it in. So if you were here, after you wired your thermostat up, this is where you would go to your control board. You would see the same markings as you would on your thermostat, except make sure that the other wire that's outdoor goes into cool and common. And if I were you, before you did anything, before you have to go in here for any reason, take your phone and take a photo of it so you know where it goes back into place. That would save you a lot of headache. So hope this helps you out with your thermostat. These are real important with what is going on within your system. Just make sure that you go over everything that you're doing with it and how you're doing your operations. And with that, guys, this is Chris with HVAC for Beginners. We'll see you on the next video.